All right, so for this one, remember, guys, that this is breaking up the vector into its x and y components. So this is v sub x, and this is v sub y. So when we sketch that out, that's saying that my resultant vector this is v sub y, which is equal to 8 meters per second. And then my v sub x is equal to 8. By the way, you should be writing this down. If you don't know how to do this problem, it'll be on the retake. Is actually this. Okay? That's what that means. And what they really want to know is they would really like to know what this angle theta is. Now to find theta, we just got to do arctan. This is in your notes. This question was on the practice test, but we didn't do a video of it because this component is in all the other problems where we have to find theta. All right. So then theta is equal to arctan. Oops, why did I do it that way? No, I want to go back to that. Oh, I gotta zoom in a little bit. There we go. All right. And we're just going to plug in our y value, which is 8. And then we're going to plug in our x value, which is 8. Okay? Do that on our handy-dandy calculator. I'm going to go to the function in Desmos. And what's 8 divided by 8 reduced down to? Just 1. But even if you didn't know that, we'll just do it like this. Whoops. And so the angle is 45 degrees. Oops, wrong thing there. So now I have the angle. That's why they say polar coordinates. But I need to know the length of V. Because right now it's written this way. So to find the actual length of V, this is also in your notes. Remember that V is equal to the square root of V sub x squared plus V sub y squared. So that's equal to 8 squared plus 8 squared. So V is equal to the square root of 64 plus 64. And V is equal to the square root of 128. The square root of 128 is about 11. Yeah, roughly about 11. So polar coordinates would be about 11 at 45 degrees. So then when we go back here, guess what? 11 meters per second at 45 degrees. And we did do that in the practice test.